All right, boys and girls, welcome back to the drive-through for a little 3-2 action. Hope everyone's having a wonderful time. Say hi to Elliot. What's up, Elliot? All right, so as always, I encourage you to pause the video and read this. So we've got a nice chart here. Use the data collected by Alonzo to interpret some keys to the relationship. Well, it seems to me that time is moving sequentially, but the depth of water is increasing and decreasing as we go. There is no relationship between the amount of time that we have spent and how deep the water gets, which makes sense. It's a river. Now let's look at Maria's graph. Okay? Maria's graph represents the total distance traveled as a function of time. So if you notice, Maria's graph is constantly increasing. It's constantly going up at some point, or it's standing still. Okay? Use the graph created by Maria to describe the key features. So it's increasing. Now, this is the first time we've officially maybe introduced this domain. When you hear domain, I want you to think inputs. Or X's. When you hear range, I want you to think output. Or Y's. Okay? All of this is alphabetical order. Alphabetical order. What do I mean? You're going to get confused of which one is the domain and which one is the range. Just remember, domain comes before range, input comes before output, X's come before Y's. So what is the domain? Well, the domain is our X values. It looks like X has to go from 0 to 120. That's where our graph stops. Our Y's look like it's going from 2,000 feet, so that's our domain. Our range is going from 0 feet to, let's see, 10, looks like each one's 2, 12, 14, 16, to 18,000 feet. So our range is traveling from 0 feet to 18,000 feet. Our maximum appears to be this point, which would be 10, 12, 14, 16,000 feet. So our maximum is 16,000 feet traveled. Our maximum as far as our axis would be 120 minutes. Our minimum would be 0 and 0. And our x-intercept is 0. Our y-intercept is also 0. Okay, so we start at 0, 0. Okay, now, we're going to have to kind of toggle back and forth between this screen and the next one. So, Sierra looked at all the data collected by her friends and made several of her own observations. Explain why you either agree or disagree. The depth of the water increases and decreases during the 120 minutes of floating. This chart is, I'm going to look to for depth, and I do believe that is a true statement. The distance traveled is always increasing. Well, this is my distance, and I do believe that that is a true statement. The distance traveled is a function of time. I do believe it is. As time increases, distance increases. The distance traveled is greatest during the last 10 minutes of the trip. The distance traveled is greatest during the last 10 minutes of the trip than, that's bad English, than during any other 10-minute interval of time. Let's look at this. So each one of these, so they're saying this right here is the fastest increase. Well, I don't really know how to compare it. It looks really close to that. I'm going to disagree with that one. It also looks like this might have been an even greater increase. I think from 40 to 50 is the greatest increase. So I'm going to say disagree with D. D on the D. E, the domain for the distance time graph is all real numbers. I think so. It's continuous. The y-intercept for the depth of the water of time is 0, 0. I agree. Oh, hold on. I disagree. I disagree. I disagree. At 0 time, the depth is 4. So I disagree with this one. I disagree with, I think it's 0, 4. The distance traveled increases and decreases over time. I disagree with that one. The distance is always increasing. The depth of water is never 11 feet. I disagree with that one. It's never 11 feet during our data points, but that doesn't mean it couldn't be 11 feet in between our data points. The range of the distance time graph, range. Shout out to Ethan. The range of the distance time graph. Let's see, let's take a look. Range is output. Remember, range is output. I agree. I do think that's the range of the output. The domain for the depth of water is 0 to 120. The domain. With respect of time, let's see. This is time, so the domain for the time is indeed, the input is 0 to 120. I agree. The range for the depth of water over time is from 4 to 5. I disagree. Just because it starts at 4 and ends with 5, there's a lot more variance on there. It goes as little as 4 but as high as 12. So I disagree with this one. I think it's 4 to 12. The distance time graphs have no maximum value. I disagree with that one. I think the maximum distance traveled, we decided, was 15,000 feet. The depth of water reached a maximum at about 30 minutes. We can test that. Nope, I believe it's at about 90 minutes. So I disagree with M too. Okay? I believe that will get you through your entire lesson. You're going to have a lot of questions on this, but rather than do examples, I'm waiting for you guys to ask me some great questions. This is a very important homework, so make sure you take your time and do it right. SynLab, boom!